The massive lecture hall of the Galactic University of Environmental Studies slowly filled with students from across the galaxy. Beings of all shapes and sizes settled into their seats, some floating, others crawling, and a few simply existing as patches of colorful mist. Among them sat Jack Thompson, the only human in the room, trying his best to blend in despite his obvious differences. Professor Dash stood at the center of the stage, his crystalline body catching the light and sending rainbow patterns across the walls. As the foremost expert on extreme planetary environments, his classes always drew large crowds. Today's topic had caught Jack's attention more than usual: survival possibilities on acid planets. "And this brings us to Xenon 7, Professor Dash announced, his voice resonating through the hall. A hologram appeared behind him, showing a planet with swirling yellow-green clouds, one of the most hostile environments in the known galaxy. Its atmosphere is composed of highly corrosive compounds that can dissolve most conventional materials within hours." The professor paused, his crystalline form shifting slightly as he turned to face the audience. "This is why only species with natural acid resistance can hope to establish any permanent presence there. Speaking of which," he gestured toward Jack's direction, though not specifically at him, "this is also why we don't see many humans venturing into these harsh environments. Their physical limitations make them unsuitable for such challenges." Jack felt his face grow warm as several students turned to look at him. He'd been auditing this class for weeks, fascinated by the subject matter, but trying to stay unnoticed. Now, he couldn't help but speak up. "Professor," Jack called out, his voice steady despite his racing heart, "what if someone could develop a way to survive there using only local materials?" The lecture hall fell silent. Professor Dash's crystalline body flickered with traces of amber light, a sign of amusement among his species. "Young man, while I appreciate your enthusiasm, you must understand that countless experts have studied Xenon 7. Its atmospheric acid concentration is so high that even our most advanced synthetic materials fail within days." Jack stood up, his chair scraping against the floor. "But has anyone tried using the planet's own protective mechanisms? The local life forms must have evolved some way to deal with the acid." "Ah, yes," Professor Dash's voice carried a hint of condescension. "The classic human approach, looking for simple solutions to complex problems. The native life forms have evolved over millions of years to survive there. You can't simply copy that in a workshop." The professor turned back to his presentation, ready to move on. But Jack wasn't finished. "I'd like to try." More students turned to stare at him. A few made sounds that might have been laughter in their respective species. Professor Dash fully turned around, his crystalline body now pulsing with deep blue light, a sign of genuine interest. "You want to try?" the professor asked. "You're proposing to go to Xenon 7 and attempt to survive there?" "Yes," Jack replied, his voice firmer now. "Give me one standard month. If I can create a sustainable protection system using only local materials, you'll need to update your teaching about human capabilities." The lecture hall erupted in a cacophony of sounds as students discussed this bold challenge. Professor Dash raised his arms, calling for silence. His body now shimmered with multiple colors, a sign that he was processing various emotions simultaneously. "This is highly irregular," he said, "but also potentially educational." He paused, crystalline surfaces reflecting light as he considered the proposal. "Very well. I accept your challenge, but with conditions." Jack nodded, already expecting this. "Name them." "First, you may only bring basic survival gear, enough for 3 days in a hostile environment. Nothing specifically designed for acid resistance beyond standard safety equipment." "Agreed," Jack said. "Second, you must document everything. We will monitor your progress remotely, and if at any point your life is in serious danger, we will extract you immediately." "That's fair." Third, the professor's voice became more serious, his body turning a deep purple. "You must accept that failure is the most likely outcome. This will be recorded and used in future lectures, either as an example of human ingenuity or as a cautionary tale about overconfidence. Jack felt a smile spread across his face. I accept all conditions. The professor's body flickered rapidly through several colors before settling on a bright white. Very well. We will prepare the necessary paperwork and arrangements. You have one standard week to prepare before departure to Xenon 7. As the lecture resumed, Jack sat back down, his mind already racing with ideas. He'd spent months studying the publicly available data on Xenon 7's ecosystem. While others saw a hostile death trap, he saw possibilities. The native plants and animals had already solved the acid problem. He just needed to figure out how they did it and adapt their solutions. The next week passed in a blur of preparation. Jack studied everything he could find about Xenon 7's native life forms, focusing particularly on the planet's unusual plant life. He packed carefully, selecting only the most essential tools and monitoring equipment. Each item had to serve multiple purposes to stay within the weight limits of his allowed gear. On the day of his departure, a small crowd gathered at the university's spaceport. Most were students curious to see the strange human who dared to challenge their respected professor. Professor Dash himself stood near the small transport ship, his crystalline body glowing with a mix of colors that suggested both amusement and concern. Last chance to withdraw, the professor offered as Jack approached with his minimal gear. No one would think less of you. Jack checked the seals on his protective suit one last time. Thank you, Professor, but I'm certain about this. Besides, he grinned, I think it's time someone showed the galaxy that humans aren't as fragile as everyone assumes. The professor's body flickered briefly. Your confidence is remarkable, if perhaps misplaced. Remember, the extraction team will be monitoring your vital signs. Don't take unnecessary risks. Jack nodded and stepped toward the transport ship. Before entering, he turned back to the professor. You know what's interesting about humans, Professor. We've survived on our own world for thousands of years, despite not having any natural armor, poison, or significant physical advantages. We did it by watching, learning, and adapting. That's exactly what I plan to do on Xenon 7. As the transport ship's door closed behind Jack, Professor Dash watched with his sensors at full sensitivity. His species had encountered many races across the galaxy, but humans continued to puzzle them. They seemed so fragile, so poorly adapted to the challenges of space, yet they constantly pushed boundaries that other species considered fixed. The small ship rose into the sky, carrying Jack toward his month-long challenge. In the crowd of observers, betting pools were already forming about how long the human would last. The most optimistic bets gave him a week. Professor Dash, however, found himself hoping that this bold human student might actually succeed. It would certainly make for an interesting addition to next semester's curriculum. The transport ship broke through Xenon 7's thick atmosphere, its special shielding glowing orange from the heat and chemical reaction. Jack sat strapped in his seat, watching through the reinforced window as the swirling yellow-green clouds parted to reveal the planet's surface. Despite the harsh environment, the landscape below was surprisingly colorful. Landing zone is 2 minutes away, the ship's AI announced. Remember, once you exit, you have 3 hours before the acid rain begins. Use this time wisely to set up your basic shelter. Jack double-checked his protective suit's seals. Understood. How long will the ship's shielding last? Approximately 6 hours. After that, the acid will begin to compromise the hull. I must depart before then. The ship landed on a relatively flat area surrounded by strange, twisted vegetation. The plants looked like a cross between Earth's mushrooms and trees, with thick, rubbery surfaces that glistened with some kind of natural coating. Jack made a mental note to study them more closely once he was set up. As soon as the ship's door opened, Jack's sensors began beeping wildly. The air was so corrosive that even the best protective suits could only last for a few days. He needed to work fast. He quickly unloaded his supplies, a basic shelter module, some food and water, testing equipment, and a few essential tools. The ship departed as soon as he finished, leaving him alone on the acid planet. Jack worked quickly to set up his shelter, a dome-shaped structure made of standard emergency materials. According to his research, it would resist the acid rain for about 48 hours, enough time to find a better solution, he hoped. Just as he finished securing the last seal, the first drops of acid rain began to fall. Each drop hit the ground with a slight sizzle, leaving small pockmarks in the rocky surface. Through his shelter's transparent sections, Jack could see the nearby plants shifting their outer layers, adjusting to the rainfall. "Fascinating," he muttered, activating his recording equipment. Professor Dash and the other observers would be watching everything through his suit's cameras. The plants aren't just resistant to the acid, they're actively responding to it. He spent the next few hours setting up his testing equipment and taking readings of the environment. The acid rain grew heavier, drumming against his shelter with increasing intensity. Each drop that hit his shelter left a slight mark, evidence that the protective coating was already beginning to wear down. By the next morning, Jack's situation had become serious. The shelter's outer layer was deteriorating faster than expected, and his protective suit would only last another day or two. He needed to find a solution quickly. Wearing his suit, he ventured out to collect samples of the local plants. The rain had stopped temporarily, but the air itself was corrosive enough to slowly eat through his equipment. He noticed something interesting about the ground near the plants. It seemed less corroded than the surrounding areas. Back in his shelter, Jack examined the samples using his portable analysis kit. "The plants are producing some kind of resin," he reported for his observers. "It seems to react with the acid and neutralize it. If I could just figure out how to extract and process it." He spent the next several hours trying different methods to collect and process the resin. His first attempts failed completely. The resin would either harden too quickly or lose its protective properties when separated from the plant. By the end of his second day, Jack's shelter was showing serious signs of damage. The dome's surface was now clouded and pitted, and small drops were beginning to seep through in places. He had to cover these spots with patches from his emergency repair kit, but he was running out of patches quickly. Think, he muttered, pacing in his increasingly compromised shelter. He was missing something obvious. The plants weren't the only things surviving here. There were also small insect-like creatures that seemed completely unaffected by the acid. He managed to catch one of these creatures in a sample container. Under his portable microscope, he noticed something remarkable. The creature's shell was covered in tiny crystals, similar to the ones he'd seen forming on dead plant matter. "That's it," he exclaimed. "The resin isn't the final form. It needs to crystallize." His excitement was cut short by a loud cracking sound. Another section of his shelter was failing. Working against time, Jack collected more plant samples and began experimenting with different ways to speed up the crystallization process. He discovered that exposing the resin to heat caused it to form crystals much faster than natural weathering. But there was still a problem. The crystals alone weren't enough. They were too brittle and would break down quickly under the constant acid rain. He needed something to bind them together. On his third day, with his shelter barely holding together, Jack noticed something about the local rocks. Certain types seemed more resistant to the acid than others. Using his analysis kit, he found that these rocks contained high amounts of a mineral that reacted with the acid to form a flexible, resistant coating. "If I can combine the plant crystals with this mineral," he began, but was interrupted by a major breach in his shelter's wall. Acid rain began pouring in through a hole the size of his fist. Jack quickly moved his equipment away from the breach and used his last repair patch to cover it. He had maybe hours left before his shelter became completely unusable. His protective suit was also showing signs of severe wear. Its outer layer was beginning to bubble and peel. "Professor," he spoke into his communicator, knowing the observation team was watching. "I think I'm close to a solution, but I'm running out of time. The local plants produce a resin that crystallizes, and there's a mineral in the rocks that could help bind it together. I just need more time to figure out the right combination." His shelter's integrity alarm began blaring. Multiple sections were now at critical failure points. The acid rain outside had intensified, and his suit's sensors were warning him about dangerous levels of corrosive compounds in the air that was now leaking into his shelter. Jack looked at his remaining supplies and the failing shelter around him. He had come to Xenon 7 to prove that humans could adapt to any environment. But now he faced a difficult choice: signal for emergency extraction, or risk his life continuing his experiments. Through his shelter's deteriorating walls, he could see the native plants standing tall against the acid storm, their crystalline coatings gleaming in the dim light. They had solved this problem through evolution. Surely he could solve it through engineering, if only he had enough time. The shelter's main support beam groaned ominously above him. Jack looked at his half-finished experiments and made his decision. He wasn't ready to give up yet. Humans had faced impossible challenges before and found ways to overcome them. He just needed to work faster and smarter. With determination, he turned back to his workbench. The acid rain pounded against his failing shelter as he began his next experiment, racing against time to find the right combination of crystals and minerals that could save his life. With his shelter falling apart around him, Jack worked frantically at his makeshift laboratory bench. The acid rain had created several new leaks in the ceiling, forcing him to constantly move his equipment to avoid damage. His protective suit's outer layer was now severely compromised, with warning indicators flashing on his helmet display. "Think like the planet," he muttered to himself, examining the crystallized plant resin under his microscope. "Nature already solved this problem. I just need to understand how." Through his suit's camera, Professor Dash and the observation team watched intently. The professor's crystalline body flickered with concern as he monitored Jack's vital signs and the rapidly deteriorating environmental conditions. Jack noticed something interesting about the dead plant matter he collected. When the plants died, they didn't just produce random crystals. They formed specific patterns, almost like a lattice. He grabbed a fresh sample and deliberately exposed it to acid. "Look at this," he exclaimed, adjusting his microscope's focus. "The crystals aren't just a barrier. They're actively channeling the acid through specific pathways." He quickly gathered more samples, testing different pieces of dead plant matter. Each one showed the same pattern. The crystalline structure wasn't just blocking the acid, it was redirecting it harmlessly away from the protected areas. A loud crack from above interrupted his work. A support beam had finally given way, creating a large gap in the shelter's roof. Acid rain poured in, forcing Jack to quickly grab his essential equipment and move to the last stable corner of his shelter. "I need to work faster," he said, his breath fogging his helmet's visor. The suit's environmental controls were starting to fail, making it harder to breathe. But he couldn't stop now. He was too close to understanding. Jack examined the mineral-rich rocks he'd collected earlier. Under the microscope, he noticed they had a similar crystalline structure to the dead plants. When exposed to acid, these rocks didn't just resist it. They changed their surface structure. "That's it," he shouted, excitement overriding his fear. "It's not about blocking the acid. It's about controlling where it goes." Working quickly, Jack ground up some of the crystallized plant matter and mineral-rich rocks into a fine powder. He mixed them together with a small amount of water from his dwindling supplies, creating a thick paste. "The crystals from the plants create the channels," he explained for his observers, "and the minerals provide the framework to hold everything together, just like the native life forms do naturally." He spread a thin layer of his mixture on a piece of his broken shelter wall. Now came the moment of truth. Jack carefully positioned the coated piece where acid rain could hit it directly. The first drops sizzled when they hit the surface, but instead of eating through the material, they seemed to roll off, following invisible channels in the crystalline coating. Jack checked the underside of the test piece. It was completely dry. "It works," he exclaimed, his voice cracking with emotion. "The acid is being channeled away, just like in the native plants." But his celebration was cut short by another structural failure in his shelter. A large section of the wall collapsed, exposing him directly to the acid environment. His suit's alarms blared warnings about critical exposure levels. Jack grabbed his mixture and quickly began applying it to his suit's outer layer. It was a desperate move, but he had no choice. If his theory was right, the coating would protect him long enough to build something more permanent. The observation team watched in tense silence as Jack covered his suit with the crystal mineral paste. Professor Dash's body had turned a deep blue color of concern, ready to order an immediate extraction if the experiment failed. Minutes passed, and Jack remained standing. The acid rain hit his coated suit and rolled off, following the channeled pathways he created. His suit's warning indicators slowly returned to safer levels. "The coating is holding," he reported, relief evident in his voice. "Now I just need to make enough to build a proper shelter." Over the next few hours, Jack refined his process. He discovered that heating the mixture made it bond better, and adding different ratios of plant crystals to minerals could create varying levels of protection. He worked non-stop, gathering materials and producing more of his protective coating. Using debris from his collapsed shelter, Jack built a small workshop area. He coated each piece with his mixture before assembly, creating a space where he could work safely. The acid rain continued to fall, but now it was just an inconvenience rather than a deadly threat. Professor Dash watched all of this with growing amazement. His crystalline body now pulsed with colors indicating deep interest and excitement. The human hadn't just survived. He had actually developed a new technology using only local materials. "Professor," Jack said, looking directly at his suit's camera, "I think it's time for a field test. Would you like to see how well this coating really works?" The professor's response came through Jack's communicator. "Are you certain it's safe? Your readings show the acid rain is particularly intense right now." Jack smiled inside his helmet. "That's exactly why it's the perfect time to test. The coating either works or it doesn't, and I'm confident it works." He stepped out from his makeshift workshop into the full force of the acid rain. The coating on his suit channeled the corrosive drops away, creating beautiful patterns as the acid flowed harmlessly off him. "The coating isn't just protecting me," Jack explained, walking around to show his observers the full effect. "It's working with the planet's natural cycles. The acid flows through the channels we created, eventually returning to the soil where native bacteria break it down. It's a complete system, just like the one the local life forms use." Professor Dash's voice came through again, now filled with undisguised admiration. "Remarkable. Simply remarkable. You've not only survived, you've created something entirely new, something that works in harmony with the planet's ecosystem." Jack began gathering more materials, already planning improvements to his design. "That's the key, Professor. Humans don't just survive by fighting against our environment. We survive by understanding it and working with it. Now, would you like to see how we can make this coating even better?" The observation team watched as Jack continued his work, his coated figure moving confidently through the acid rain that had nearly killed him days before. He had done more than prove humans could survive on Xenon 7. He had shown that human ingenuity, combined with respect for natural systems, could overcome even the most hostile environments. And this was just the beginning. Jack had 10 more days to refine his invention, and his mind was already racing with possibilities for improvement. The acid rain continued to fall, but now it wasn't a threat. It was an opportunity to learn more about this fascinating world and humanity's place in it. Word of Jack's success spread quickly through the Galactic University. The observation feed from his suit had become the most watched channel in the school's history, with students and professors from all departments tuning in to watch the human refine his invention. Jack, however, was too busy to think about his audience. His basic coating worked, but he knew it could be better. He spent hours watching the local insects, particularly fascinated by their nest-building techniques. "Look at this structure," he said, carefully approaching a large nest that hung from one of the twisted tree-like plants. The nest was shaped like a teardrop, with acid rain flowing smoothly around it rather than eating through it. Using his scanner, He analyzed the nest's composition. Amazing! The insects aren't just using one layer of protection. They're using multiple layers, each with a different crystal structure. Professor Dash's voice came through his communicator. Are you suggesting your current coding could be improved using a similar method? Exactly, Jack replied, excitement clear in his voice. Right now, our coding channels the acid in one direction. But if we create multiple layers, each with its own channel pattern, he paused to take more readings of the nest. We could control exactly where the acid goes, and maybe even collect it for useful purposes. He returned to his workshop, which he had expanded using his coded materials. The space now included a proper research area, and even a small living quarter. But more importantly, he had built several testing stations where he could experiment with different coding combinations. Over the next few days, Jack developed and tested various multilayer combinations. Some failed spectacularly, dissolving within minutes. Others showed promise but weren't practical to produce. Each failure taught him something new about how the planet's natural defenses worked. The key, he explained to his growing audience, is understanding that this isn't just about protection, it's about adaptation. He held up a piece of his latest experiment. Each layer needs to work with the others, just like the different species on this planet work together to survive. His breakthrough came while watching a group of small flying creatures during a rare break in the acid rain. These beings would land on certain plants, and their feet would leave tiny marks that later seemed to protect those spots from acid damage. They're not just marking their territory, Jack realized. They're helping the plants create better protection. He quickly collected samples of the marked areas and analyzed them under his microscope. The results were surprising. The creature's feet carried tiny organisms that reacted with the plant's natural resin, creating an even stronger protective layer. This discovery led Jack to completely rethink his approach. We've been trying to copy the end result, he told Professor Dash through his suit's camera. But what we should be doing is copying the process. He began mixing new batches of his coding, this time including carefully cultivated samples of the beneficial organisms he'd discovered. The new coding was a dramatic improvement. Not only did it last longer, but it could also self-repair minor damage by reacting with the acid rain itself. Jack spent several days testing different combinations and ratios, carefully documenting each result. Other alien students started sending questions through Professor Dash, eager to learn more about Jack's methodology. Many were amazed by how he combined different natural processes into a single solution. Human ingenuity isn't about creating something entirely new, Jack explained during one of his regular reports. It's about seeing connections that others might miss and bringing different ideas together in new ways. He demonstrated this by creating several variations of his coding, each designed for specific purposes. One version was perfect for buildings, another for vehicles, and a third for protective clothing. Each used the same basic principles but was optimized for its particular use. Professor Dash's crystalline body now regularly displayed colors of excitement and approval as he watched Jack work. "You've done more than just survive here," the professor commented. "You've shown us a completely new way of approaching environmental challenges." Jack's most impressive innovation came near the end of his third week on Xenon 7. He had noticed that during certain times of day, the acid rain became significantly stronger. Instead of seeing this as a problem, he saw an opportunity. "If we modify the coding's channel slightly," he explained while setting up a new experiment, "we can collect the strongest acid and store it safely." He built a small collection system using his coded materials. This acid could be useful for all sorts of industrial processes. We're not just defending against the environment anymore. We're working with it. The observation team watched in amazement as Jack's acid collection system worked perfectly, gathering the corrosive liquid into specially coated containers without any leakage or damage. Students from the engineering department began sending in suggestions and questions about possible applications. Some wondered if similar principles could be applied to other hostile environments. Others were already thinking about how to mass-produce Jack's coding. The possibilities are endless. Jack said, looking out at the acid rain that no longer posed any threat to him. But what's most important is that we've proven something vital. There's no such thing as an impossible environment. There are just challenges we haven't understood yet. By the end of his 4th week on Xenon 7, Jack had developed a complete system for not just surviving but thriving in the acid environment. His workshop had expanded into a small research station, protected by multiple layers of his improved coating. He had even started growing some earth plants in specially coated containers, proving that with the right protection, even non-native life could survive here. Professor Dash called in one evening as Jack was documenting his latest improvements. "The university board is extremely impressed with your work," the professor said, his crystalline form glowing with multiple colors of approval. "They've suggested that your coating system could revolutionize how we approach colonization of hostile environments." Jack smiled inside his coated helmet. "That's good to hear, Professor. But I hope they understand that the real lesson isn't just about the coating." "Oh." The professor's colors shifted to show curiosity. "What would you say is the real lesson?" "That success in any environment doesn't come from fighting against it or trying to overpower it," Jack replied, watching the acid rain create beautiful patterns as it flowed through his collection system. "Real success comes from understanding, adapting, and working with what's already there. That's what humans do best. We observe, learn, and find ways to fit into new situations." The professor was quiet for a moment before responding. "I believe you've taught us all something important about the true nature of adaptation and survival. Perhaps it's time we updated more than just our curriculum about human capabilities." On the final day of Jack's challenge, a special transport ship descended through Xenon 7's acid clouds. Unlike the standard ships, this one was coated with Jack's newly developed protection system. Inside was Professor Dash himself, along with a small team of university officials who had come to verify Jack's achievements in person. Jack stood outside his research station, watching the ship land. His original emergency shelter had evolved into an efficient compound, with several buildings connected by covered walkways, all protected by his multilayer coating. Collection systems gathered acid rain for research, and small gardens tested the growth of earth plants in specially designed containers. The ship's door opened, and Professor Dash emerged, his crystalline body protected by an extra layer of Jack's coating. The professor paused, letting the acid rain hit his surface, watching as it flowed harmlessly away through the engineered channels. "Remarkable," Professor Dash said, his body glowing with multiple colors of amazement. "Simply remarkable. The coating works even better than I expected." Jack smiled and gestured to his compound. "Would you like a tour, Professor? I think you'll find the improvements we've made quite interesting." The professor and the university officials followed Jack through his research station. He showed them his testing areas, where different versions of the coating were being evaluated. He demonstrated his acid collection system, which was now producing useful chemicals for various applications. "What impresses me most," one official commented, "is how you've integrated everything with the planet's natural cycles. This isn't just survival, it's true adaptation." Jack led them to his latest project, a greenhouse where he was growing earth vegetables in specially coated containers. "The coating doesn't just protect against the acid," he explained, showing them healthy tomato plants. "It can be modified to allow specific nutrients to pass through while blocking harmful elements." Professor Dash's body pulsed with bright colors of excitement as he examined the plants. "You've gone far beyond the original challenge," he said. "This could revolutionize how we approach colonization of hostile environments." "That's not all," Jack said, leading them to his research lab. He pulled up his detailed notes and diagrams on a protected screen. "The principles we've discovered here could be applied to many different environments. It's not just about acid resistance, it's about understanding how local life forms adapt and then applying those principles in new ways." The university officials took careful notes as Jack explained his findings. He showed them how the coating could be customized for different purposes, from building materials to protective clothing. He demonstrated how it could be produced using only local resources, making it sustainable and cost-effective. The key breakthrough, Jack explained, pointing to his microscope, was understanding that we didn't need to fight against the environment. The local life forms had already solved these problems through evolution. We just needed to learn from them and apply their solutions in a systematic way. Professor Dash moved closer to examine the microscope slides. His crystalline form flickered with colors of deep thought. You know, Jack, when you first proposed this challenge, I thought you were being foolishly optimistic. But now I see that I was the one being foolish. How so, Professor? Jack asked. I assumed that because humans lacked natural protections against harsh environments, you would be limited in your ability to adapt. But I failed to recognize that your true strength lies in your ability to observe, understand, and innovate. The professor turned to address the other officials. We need to completely revise our understanding of human capabilities. They don't just survive, they find ways to thrive in conditions we thought impossible for them. One of the officials stepped forward, her gelatinous form rippling with interest. The university board has already voted. We want to establish a permanent research station here on Xenon 7, with you, Jack, as its first director. Jack's eyes widened in surprise. Really? Yes, she continued. Your work here has opened up new possibilities we hadn't considered. We want to continue studying your methods and see how they can be applied to other challenging environments. Professor Dash's body glowed with approval. And I would like to officially update my curriculum. Instead of teaching about human limitations, I'll be using your work as a prime example of adaptive problem solving. Jack walked them to his acid collection system, where the corrosive rain was being transformed into useful resources. You know what the most important lesson from all this is? He asked. The group waited for his answer. It's that we should never let our preconceptions limit what we think is possible. Every environment, no matter how hostile it seems, contains its own solutions. We just need to be humble enough to learn from it, and creative enough to apply those lessons in new ways. Professor Dash extended a crystalline appendage to shake Jack's hand. Well said. And I believe you've taught us all something valuable about the importance of keeping an open mind. Over the next few days, news of Jack's success spread throughout the galaxy. His coding system was already being adapted for use on other harsh worlds. But more importantly, his approach to problem solving, learning from local ecosystems and working with natural processes rather than against them, was being studied and applied in various fields. On his last day at the original research station, before the expansion work began, Jack stood in the acid rain, watching it flow in beautiful patterns across his coated suit. Professor Dash stood beside him, both of them observing the hostile yet fascinating world around them. What's next for you, Jack? The professor asked. Jack smiled, looking up at the yellow-green clouds swirling overhead. There are so many other impossible environments out there, Professor, and I bet each one of them has something to teach us, if we're willing to learn, and willing to challenge our assumptions about what's possible, the professor added, his crystalline form glowing with newfound wisdom. The acid rain continued to fall, but it was no longer a barrier to human exploration. Instead, it had become a reminder that every challenge contained its own solution, waiting to be discovered by those with the patience to observe, the wisdom to learn, and the creativity to adapt. As Jack walked back to his research station, he couldn't help but smile. He had come to Xenon 7 to prove that humans could survive here. Instead, he had proven something far more important, that the greatest discoveries come not from conquering nature, but from learning to work in harmony with it. The future was bright with possibilities, and somewhere out there, other impossible worlds were waiting to share their secrets with those brave enough to listen and learn.